So what we are working on today is determining the molecular formula from percent composition. Percent composition looks like this. Molecular formula is something like this. So that's the goal. To go from percent composition to molecular formula. And this so happens to be ethanol, the active ingredient in beer. And historically speaking, this is a lot of work to figure this out. They had to do a lot of filtering, do a lot of boiling, and get the pure components of beer out. And then they had to figure out, do some analyses to figure out, okay, I have 50% carbon, 30% hydrogen, 35% oxygen. And that's all they could get. And then a while later, they needed some more engineering so they could do a little more complicated analyses and actually get the empirical formula. And it's a good exercise for us, but it's really not very applicable. Because right now, if you wanted, I don't know, if someone has a drink or whatever, we just go upstairs to something called a high-performance liquid chromatograph, right upstairs, or a gas chromatograph. We inject it in there. It separates everything out into the pure components, and it tells you a best guess for everything in there. And its guesses are usually pretty good. So, but it's a good activity, right? If you take more advanced classes, you'll get to play with those instruments upstairs. But okay, where are we at? We need a game plan to go from percent composition to our final answer of molecular formula. And here's our game plan. The game plan, I think, the backbone of this game plan, it might help if you understand this. If you had what would be a S2O6? I'm just making something up. That is our molecular formula. Just pretend. The 2 and the 6, are those gram ratios or mole ratios? Like, they're mole ratios. This 2 and this 6, that means that there's 2 sulfur moles for every 6 moles of oxygen. So those are mole ratios. Now that's the backbone of this whole game plan. Let's just get mole ratios. That's all it is. So you're going to start with percent composition. Well, we can't get moles out of percents, so let's assume you have 100 grams. You could pick any grams you want, but there's a real advantage to picking 100 grams. You pick 100, all the percent signs just turn into grams, right? If you have, I don't know, 50% oxygen, well, assume you have 100 grams, then you have 50 grams of oxygen, right? So just assume 100 grams. You can assume any grams you want, but assume the 100. It's so much easier. Just erase the percents and put G's. And then we'll convert to moles. Okay. So we'll have these moles, but we need ratios, and we can get the simplest ratio if we divide through by the smallest number we get. So we'll convert all these different elements into moles. You look at all those numbers, oh, this one's the smallest. So you divide all the numbers by the smallest one. And when you get that, you're going to get whole numbers. But you don't have your final answer. You might have SO3, right? Just pretend. You might have SO3. It's the simplest ratio. So here's the real answer. That's the real answer. But we just got the simplest ratio. They call that the empirical formula. That's what the empirical formula is. It's the simplest ratio. Simplest ratio is the empirical formula. Okay, well, we don't want the simplest ratio. We want the actual answer. How do you get the actual answer? Well, they're going to have to give you the molecular weight. They have to give it to you because you don't know what the formula is. If you knew what the formula is, you could, right, it would defeat the purpose. You don't know what the formula is, so you can't calculate molecular weight. They have to give it to you. But you can get this one, empirical weight. How do you get empirical weight? Remember, weight is just another term for molar mass. So you don't know the actual molar mass, but you can get the empirical molar mass. Get the empirical molar mass from the empirical formula. Easy. So add a sulfur and 3 oxygens from the periodic table, you'll have the empirical molar mass. They don't call it the empirical molar mass, they call it the empirical weight. That's just terminology you have to get used to. So divide the molecular weight that they give you by the empirical weight you calculate, and in this case, you would get what number? We're off by a factor of what? SO3 to S2O6. Right? These little coefficients, this is actually a 1. They're off by what? A factor of 2. So in this, if this was the question, you divide the molecular weight, which they give you, by the empirical weight, which you calculate, you're going to get 2. Oh, I got 2. So my answer is S2O6. Right? Just multiply the subscripts by that little n. And n is molecular weight over empirical weight. Okay, make sense? So let's clean this up so you can follow the game plan here. Okay, let's try this. We'll try this together, this first one. So we're right here. A compound that's 80% carbon, 20% hydrogen. Molecular weight 60. So, Allison, what's the first thing I'm supposed to do here in this game plan? Assume 100 grams. So all the percents turn. I don't have 80% carbon. I have 80 grams of carbon. And I don't have 20% hydrogen. I have 20 grams of hydrogen. Okay. Let's see. Carbon is like 12.01, right? Hydrogen is like 1.01. Because I need to convert into moles. So 80 divided by 12.01, I get about 6.666. And 20 divided by 1.01, about 19.80. Okay, let me just show you a common mistake right here. C, right, 6.66. H, 19.8. That's technically correct because they're mole ratios. But we don't like decimals for, this is supposed to be the number of atoms, right, in that formula. So we don't like that. So what's the next step? It's divide by the smallest. We need the simplest ratio you can get. So it's a very common thing. People forget to divide by the smallest, and they stop there. So don't do that. So I get 1 for the carbon, and 19.8 divided by 6.66, about 2.97. So I really have C1, H, 2.97. But 2.97, that's really, it's pretty much the same as what? 3. So my answer, empirical formula, is CH3. That's my empirical formula, my simplest ratio. Okay. The next question is, we're after this molecular formula. What's the exact? So this, our exact answers, either this is right or we're off by a factor of 2, 3, 4. See the possibilities? If you're off by a factor of 4, it'd be C4H12. I have to multiply by 4, right? C4H12. So we don't know what the answer is. To get the answer, we're going to have to do this last step. And they're just kind of breaking into slow parts here. What's the empirical weight, right? They want you to get this number. Well, how am I going to get the empirical weight? Erica, what am I going to do to get the empirical weight? Yeah, add how many carbons? 1 of them and 3 hydrogens. Right, so 12.01 plus 3 times 1.01. Easier just to do that in the calculator and to write it all out, but 12.01 plus 3 times 1.01, about 15.04. There's my empirical weight. It's just the molar mass of the, what formula? Empirical formula. And the more you use the terminology, the easier the game plan will get. Okay, what is the molecular formula? We have to figure out what factor we're off by. So we're going to use this. Divide the molecular weight by the empirical weight. They have to give you the molecular weight. Where did they give it? Here it is. They gave it to us. It's 60. So we're going to divide my little n, the factor I'm off by, is going to be 60 grams per mole, divided by 15.04 grams per mole. And it's going to be really close to 4, right? What did you get? 2.98? 3.98. Thank you, Clarissa. 3.98. Well, that's really close to 4. I'm off by a factor of 4. So my final answer is going to be C what, H what? Oh, yeah, that last guess we made, C4H12. That is the molecular formula. Okay. So to go from percent composition to molecular formula, assume 100 grams, erase the percents, change them to grams, convert everything to moles, divide through by the smallest answer you get. Then you'll have the empirical formula. They have to give you the molecular weight, divide it by the empirical weight, and you get your little factor you're off by. Multiply the factor by the subscripts. Okay. Now before we go to the boards and work this stuff out, there's always a catch, right? There always is. So let's show you the catch. Let's do this in purple. Okay, let's pretend I didn't get 1 and 2.97. Let's pretend I got 2.25 and 3. Just pretend. Right? Because we divide it through by the smallest. We're supposed to get whole numbers here, right? Or like 1.98 or something. That's really nice to round. You can't round 0.25. It's way too much. You have to multiply both of these by something to get whole numbers. By 4. Now, Oscar knows 4 because he recognizes 0.25 as 1/4, a quarter. So that's why he's multiplying by 4. So multiply that by 4, multiply that by 4. I'll get 12 and 8, 9. So then I'd have C9H12. Because you can't round 0.25. Because if you did, you'd say your answer is C2H3. That's a very different ratio than C9H12. So why didn't we do it originally? We did it originally because we erased it, but we had like 0.98. You can do the rounding as long as it has to be really, really close. Okay. So there's 0.25 is one to worry about. What's another one that you can see you got to worry about? You didn't get 0.25, you got 3.5. 3.75 is a real problem. You messed up somewhere. There's nothing to multiply that's easy. So that's a hint. Now you have to multiply both of them by 2, because it's at 0.5. So I'll have 2 and 7. C7H2. Okay, there's only one more. And we'll write them all down for you. I just wanted to show you. There's one more. Let's say 3.333. Right? And 1. Now multiplying both by 3. So that's what, 9.999? So I'll have a 3 down there and a 10 up there, 9.999. So C10H3. So just to put all this together in one spot, let's do this one. If you have 0.25, multiply it by what? 0.5, multiply it by what? 0.333, multiply it by what? 0.25 is multiplied by 4. A half multiplied by 2. And the 0.333? Okay. There is one more. I don't know if it's in the homework or not, but I've seen this. What's 0.125? It's an eighth. So multiply by 8. Now, I don't know. That one's kind of rare. I don't know if you'll see it or not. But Tegan asked, what about 0.75? You screwed up. These are the only real possibilities, right? Oh, there would be 0.2 would be times 5. But it has to be something really straightforward, like that. So if you get a decimal, one of these can't round it. Multiply everything to get whole numbers. That's, to me, is the trick to doing this. The rest isn't so bad. So let's go to the boards, and we can work on this together and do a couple of these, and then we can call it a day. I've got chalk up here if you want some new chalk. Okay. So sorbic acid is a mold inhibitor. Its composition is 64.3% carbon, 7.2% hydrogen, and 28.5% oxygen. What's the empirical formula? We can jump over there next to Christian. There's a lot of space over there. Turn on the light for you. So remember the steps. Get everything in grams. Convert the grams to moles. Divide through by the smallest. All right? One step at a time, but don't skip any of them. And when you get to moles, make sure you carry at least, 3 digits or so, because otherwise your ratios may not work out so well. So the less rounding you do, the better to get there. Need a calculator? Need a periodic table?
Yes.
Looks good so far. Mm-hmm. Yeah, take 7.2 divided by 1.01. Mm-hmm. Yeah, whatever you get. Write down at least 3-4 digits, though. Because then when you divide through by the smallest, it'll work out. So, Annabelle, that's good. You're doing good. So when you're converting to moles, make sure you write down at least 3-4 digits. Otherwise, sometimes your ratio won't work out. Oh, you divide through by the smallest, right? The common mistake. To get the simplest ratio, you have to divide through by the smallest. All right, so your smallest is going to be this one. Yeah, good. That's good. That's good. And I'll do this one. 3-4 digits is all you really need. All right, so did you divide through by the smallest? Yes. You divide by ham, divide by ham. Oh, and that's what these are?
Yeah.
Okay, good. I see a lot of people getting C3H4O as an empirical formula. If you're getting C3H4O, I think you're doing it right. Make sure your neighbors are getting it. Did you get it? Yeah, so now you just have to put, these are all whole numbers. There's no trick like 1.25 or anything. So these are your subscripts. C, this is carbon, right? So C3, this one is H, H4, that one's O. So C3H4O. C3H4 and oxygen. Yeah, and you can put a 1 down there if you want, because it's a 1. All right? So that's your empirical formula. And then they said the molecular weight's 112. So if the molecular weight's 112, what's the molecular formula? You have to add 3 carbons, 4 hydrogens, and an oxygen to get the empirical molar mass, the EWT.
But do we have to multiply?
Well, 3 times 12. Yeah, 3 times 12 plus 4 times 1.01 plus 16.01. Yep. Okay. Now you have to, Daisy, you have to divide through by the smallest.
Do I keep the numbers like that?
No, that's fine. This is good. You can carry 3-4 digits.
I don't
Now you divide by 1.7. Divide everything by 1.78. Because that's your smallest number, right? Oh, they erased it.
Oh, okay.
That's okay. That's all right. Oh, she's still got it over there.
Number 3.
Mm-hmm.
All right, so you get that for the percentage of.
Yeah, you could do that.
Oh,
That's your percent tungsten.
Yeah.
But there's 5.34 grams of stuff.
Yeah,
There's
so
another element in there.
Yeah,
What's
so
the other
You
element?
divide, it's oxygen, right?
Yeah.
Oxide, so, yeah.
So how are you gonna get its percent?
Whatever 5.34 minus 2 or 1.
Or, that's the hard way, or take 100 minus that. Right?
Yep, got it.
Okay, if you got the final answer of C6H8O2, try the next one. If you didn't, let me help you. Yeah. So that's your empirical formula. Yeah. There you go. Is it 41.83? They have 56. It's 3 carbons, 4 hydrogens, and an oxygen. I see 56 down there. Whoa, no. You have to find the empirical molar mass of this. So use the periodic table. 3 times 12 plus 4 times hydrogen, 4 times 1.1 plus 16. So it has nothing to do with these numbers.
Oh, that's true. It's because
These guys, right?
Yeah, but it's because I was doing these,
Oh.
and then I added this.
Yeah, okay. But you see. So try it. You should get 56 down there.
I can turn this off. I don't know how I did it, but I know I did it.
We don't really need it anyway. Oh, you did turn it off. We don't need it anyway.
Right here, we're finding out the molecular formula. So, right?
Yeah. So now you have to divide the molecular weight by the empirical weight. So find the empirical molar mass. 3 times carbon, right? 3 times 12. 4 times, what is that, 1.01 for hydrogen? And 1 times 16. Add all that up, right? And divide 112 by what you get, and you'll get like a 2 or something. If you get a 2, the answer would be C6H8O2. Yes. Yes, then you'll have the exact right answer. Oh, we need this on for the next class. Yep. Tungsten, yeah, Oscar, that's the trick. Recognize what the 2 elements are. It's tungsten and oxygen. So you need to figure out the percents of each or the grams of each. Either one is a good starting point. Yep, that's what people are getting. C6H8O2. Danielle, something happened. The empirical would be right, C3H4O. Oh, that's a 4. I see.
Yeah.
You got it. Oh, I couldn't see. I thought that was a 9. Okay, you got it. You're good. Okay. Now, if you don't see the trick to number 3, let me help you out. You don't see it? Okay. In number 3, you've got, in number 3, you have 2 elements. You have this tungsten, but that's only 4.23 grams. You have 5.34 grams total. Yeah, subtract the 5.34 minus the 4.23. And then you'd have the grams of what? Grams of oxygen. That's how you get the grams of oxygen. And then you can start from there. Skip this whole percent thing. Or you can calculate percents and go from there. Right? But I say you just start from here. You have 1.11 grams of oxygen, convert that to moles. Do the same thing with the tungsten. Convert the 4.23 grams of tungsten into moles. Oh, I bet it will be. It's number 74. Molar mass of 183.84. Get the moles of each, divide through by the smallest. You erased everything. What did you get? Tegan, what did you get as the final answer? Yeah.
I got W206.
So you had to multiply that guy by 2 then, the W03. Okay. Okay, now you got to divide through by the smallest. What's the smallest number? Yeah, so divide through by that one.
Divided by?
Yeah, because this right now all you have is like the
What's tungsten?
It's right there.
Oh, the W.
Yeah. They kind of gave you a hint.
Oh, there it is.
Yeah. That's it, Tegan.
Can I take the quiz from last class since we had a game?
Yeah.
Oh.
Yeah. Take it between now and 1.
Do you have it right now?
Yeah, we have to, after class we have to go get it. Yeah, so whenever you're gone for a sport, you can either take the quiz before you leave or that following class period, 11 to 1. Yeah, that's good. Yeah, so you can take the exam before you leave or Monday from 11 to 1. Yep, it's very good. Yeah, we're done. That's it. So for our pizza help session, if you can make it, this is one of the things I think will be interesting. A student gave me some of the Mexican Coke, right? Remember we talked about how it's supposed to be better than American Coke?
Yep.
So we'll do a blind study here and see if you agree.
When I go to, I don't drink Coke when I go to Mexico.
Yeah? Yeah, really? You don't like it? Huh. Uh-huh.
Once I get here with these small numbers.
Now this is a 1, right? Oh, that's your answer. 0.02? Oh, I see what you're doing. This is a 1. And equals, right?
1?
No, you said 0.069 or 0.06 or something, right? So this is
Is that wrong?
They don't have. That's not the percentage. That's the.
no, it's okay.
You can do that?
You can do it.
Okay.
You can do it your way. Your way is sticking to the game plan.
Okay.
And she kind of stuck to the game plan. She just skipped percents.
Okay.
And she went to grams. So either way, you get the exact same answer.
Making sure.
Get the exact same answer. So you take the grams of oxygen, so the molar mass all over the, right, 1 mole of the stuff. This is always a 1, because that's how it's defined.
Right.
Yeah, it's always a 1. So this divided by 16, you got this. This divided by that, you got that. Next step, divide through by the smallest. What's the smaller number?
Oh.
Yeah, this is the smaller
Okay.
number.
I was like,
Yeah. So it's the hardest step to remember. Divide by the smallest. If you remember to do it, you're going to be fine. Then you got it. Yep, Oscar, we're done.
All right,
Have a good day, guys.
Oxygen 3W.
Yep, you got it. Now you have to find the molecular formula.
Which is
Empirical or molecular weight over empirical weight.